Now, if you read PBL 2.2, PBL 2.2 need to do something called load balancing before we can do the calculation. So these are the information provided to us. So we should pay attention to a few important information there. For example, we are dealing with a switchboard. Wow, the pen is so thick. We are dealing with a switchboard, which is something that somebody can say, tell me whether this thing switchboard is not. Okay, all right. So what's happening now is that I am given the number of circuits in this switchboard. So the best thing to do is every time somebody give you something like this, the first thing to do is to sketch out for yourself to see how would the single line diagram look like first. So you have some idea first. So that's the way to go, right? So if I were to do that, what I can do is, okay, let me use a PowerPoint file here. Let me use a PowerPoint slide to illustrate this thing. All right, so if I were to read this PBL, and I try to imagine how my single line will look like, I can draft something like this. I can draw something like this. Okay, so now this is a sub switchboard, SSB sub switchboard. So there is an incoming supply, and then outgoing, I have many circuits. So if you look at this, this is nothing new. This one, if you look at your lecture note, we have been drawing this all the time, right? So you can start doing things like that. That means if you go and look at your, let me just pull out one of the lecture note of topic. Let me pull up the topic. This is a lecture note. If I look at the lecture note, you'll find that a lot of times whenever we talk about single line diagram, or rather whenever we talk about electrical installation, we always draw something. We try to draw something, so that gives me an idea how my single line is going to be like. All right. So it's always good to do that. Whenever you are asked to do a design, you try to draw something first. When you draw something, then you can apply the calculation like what we have in the lecture notes. Okay. So this is what I'm trying to tell you. So if I were to go back to my PBL 2.2, right? The PBL 2.2 never give me a single line. So I try to imagine how it will look like. So if I look at it, how many circuits are going out based on this one? How many circuits do you think there is? Hello? Anybody can tell me how many circuits are we going to draw? No? Anybody else?
Right.
How many circuits are we going to draw?
5.
5. 1, 2. This one, look carefully. This one, how many? 3, 4, right? 5, 6.
Or 6.
Yes. Right. So I will have to draw 6 circuits. So 1, 2, 3, 4, 5. So not enough. So I will need one more. Okay. In other words, my single line diagram will look something like this. Of course, I need to fill in the blank. Later on, there are other things I need to fill in. So roughly, this is the outline of how the single line diagram will look like. Is that okay, everybody? Hello? Hey guys, if you all keep quiet, I have no idea whether you all know what I'm talking about. I need some response, please. Faizal, are you here, Faizal? Mama Faizal.
Yes.
Mama Faizal. Now this we talk about that there is 6 circuit here, right? Are you clear about the 6 circuit? So can you name me the first circuit? First circuit is what type of circuit?
DBA.
DBA, right? So in other words, at the end of the first circuit, I have DBA connected to it. All right, so this one, let's call it circuit number 1, circuit number 2, circuit number 3, circuit number 4, circuit number 5, and circuit number 6. All right, then the second circuit is the what? Dongkang is not here. Ryan, second circuit is what kind of circuit? At the end of the circuit is connected to what?
Sorry, can you repeat yourself, sir?
At the end of the circuit for number 2, what is it connected to?
What is it connected to?
Okay, maybe I didn't make it clear. Let's follow this way. This is circuit number 1. Okay, this is circuit number 1. This is circuit number 2, circuit number 3, number 4, number 5, and number 6. Just now we say there are 6 circuits going out, right? So circuit number 2, if I want to draw something on my single line diagram, what should it be? Huh? Right?
I'm not sure, sir.
Not sure. You look at this. Circuit number 2 is the what? It's connected to what?
Lighting and power.
It's a DB again, right?
Oh.
Okay. So it's
Or
a
distribution board again, okay.
okay. That's what I'm trying to clarify.
Okay.
That means this one comprises of lighting and power circuits. Then comes circuit number 3 and number 4. Lester, what is connected to the end at the end of circuit number 3 and number 4?
那个motor
Okay, so I have 2 motors. They are the same type. So I have a motor.
So do we connect them in the same circuit or what?
No, we cannot. Motor, we usually supply 1 circuit to 1 motor. Okay, we cannot share. We try not to share because motor generally are bigger loads, so we cannot share the circuit. All right. So if I were to look at this, right, I try to write out all the information there. Whatever information provided to me, I try to write it down. For example, this motor is 22 kilowatt. Okay, 22 kilowatt. And it is 3-phase. It is 3-phase. It is 3-phase, and then its power factor is 0.8. So all this kind of thing you have to write down. You have to write down in your single line diagram. And lastly, power factor is 0.8. Efficiency is 0.83. Right? So these 2 motors are the same. But whenever we use a motor, we have to protect it with a starter. So a motor has a starter. So I will draw the circuit like that. Okay, circuit number 2 and number 3, number 3 and number 4 like that. Then what about number 5? Nadia, what is connected to circuit number 5?
Motor.
Also another motor, right? But this time it's air compressor. All right. So circuit number 5 is also a motor, because air compressor is a motor as well. So I have another motor here. So I will need another starter here as well. Right. This time the air compressor is 7.5 kilowatt. It is 3-phase. So this is just a tentative. Whenever you read something like that, you take out a piece of paper, you try to write it down. Write it down so that you can see for yourself how your single line is going to look like. Efficiency is equals to 0.88, things like that. All right, and then my last circuit is a molding machine. Now, usually machine, I would deem it to be a motor as well. So this one is 1.5 kilowatt. But this time, this one is single phase. So these are all important information. So I need to be very clear. What am I doing? It's equals to 0.85. And the efficiency is 90%. Oops. The efficiency is 90%. Oh, okay, never mind. Let me open up. See. All right, the efficiency for this motor at the end here is 90%. Right, so based on this, based on this information, let's create more space on this. So based on this information, I need to do some calculations. All right, I need to do some calculation because my objective is to be able to gather enough information to finally draw this single line properly with all the required information all inside there. Right, so the guideline given here is, first of all, I identify all electrical load, which is what I'm doing. Right, I list all the electrical load here. And then I identify very clearly which are single phase and 3-phase. Okay, I haven't really finished all. Like this guy is single phase only. Whereas this guy is 3-phase. So each one of this information will means that I have to use the necessary method to do the calculation. Like this one is 3.5 kilowatt. Okay, and it has a power factor also. So all this, if I can write everything down into a piece of paper, then it's easier for me to see and later on for me to do my calculation. So that's the first thing I would like to encourage all of you to do. Now the question mark is this one. This one I have at the moment what is given to me is not good enough because I don't have the power. There is no way for me to know what is the power at the moment. Okay, I'm going to pause for a while. Anybody got any question to ask about what I've been talking of?
So this is similar to the PBL2, PBL2 point some PBL1, right? Except that it is 3-phase, am I right?
Correct.
Oh.
Yeah, correct. Right. This one is a more complicated version compared to our PBL1. Because PBL1 is single phase. So everything coming is always in the same phase. So I don't have to worry about load balancing and all this. All right. Clear enough. So this one I have to do something later on. So the first step is to try to come up with the idea how the single line is going to look like. And then I try to apply the calculation from topic 3 and topic 5 to get the information that I want. Right, there's some information I realize now is missing here. Can you notice that in this particular information, I have one more column where they have the type of starter. So every time somebody give you the type of starter means the circuit is a machine or motor circuit. So I should be writing that one down as well. So what happened is that now with that information there, I can actually write down here. Okay, this one is a star delta starter. Star delta starter. This one is a DOL starter. All right. So if I were to identify all the things that I need to do, the first thing I need to do is I need to find out what is the circuit breaker rating for each one of this guy. Circuit number 1, number 2, number 3, number 4, number 5, number 6, and more importantly, this big one. I call this IM prime. Okay, so that is the whole objective of calculation, the calculation part for this PBL 2.2. In other words, I need to do all the calculation and finally get the answer for every one of this guy. Right? Once I have finished the calculation, then I can do this number 4 here. Otherwise, I cannot complete my single line diagram. Okay, so I must do all this first. Calculation, finish all my calculation first. Right? So if now I look at this single line, okay, I'm going to move this away. So I'm going to push this away. I look at this single line and I ask myself, what is it that I must do in order to do my calculation? Okay, so I need to find a way to do that. Now, can anybody suggest what should I do from here? Now I help you to draw an idea outline of the single line already. So what is my next step?
Calculate the load, right?
Very good, Lester. Right, I want to do the calculation for the load. All right, so let me maximize this screen. So now I have a very rough idea of the single line diagram. I want to calculate the load. Right, I want to start my. Ultimately, we want to find all these. Right, so the first step is I want to calculate IN1. So can anybody tell me what they have learned? How do I find the answer for IN1? Ethan, are you there, Ethan? Ethan not here. Ethan went home already. Ethan, are you here? Or? Maybe I should mark Ethan absent. Sihan, I want to find the value of IN1. How do I find the value of IN1?
You divide.
Divide by what? Where do I start first? Where do I start? Ethan, I asked you a question. Now I help everybody to draw the single line for PBL 2.2 already. I want to calculate all these values, IN1, IN2 until IN6, and also want to calculate the circuit breaker rating here. So where do I start the calculation?
Calculate the IFL, is it?
Very good. Okay, let's start with one. Okay, let's start with this IFL. How do I calculate the IFL for this one?
Use the power, then you divide.
Okay, power, then we divide. So power divide by what?
Voltage.
Divide by the voltage, then?
Times power factor.
Times power factor, very good. Times? One more. Times what?
√3. No.
Efficiency, not √3. Wait first. This is single phase.
Efficiency, yes.
Remember this is single phase.
Yeah.
Okay, so I use this formula. The power is 3500 watt. Divide by, what is the value of V?
230.
230 watt, because this is single phase. Multiply by the power factor, which is 0.85. Now, every time efficiency not given, I assume that it is 1. So from here, I can get the current. So can you calculate for me what's the current?
$17.9.
Thank you. Okay, so this current here is 17.9. Can the rest of you check whether Ethan's calculator is working now? Can you all check for me? Ethan's calculator is working now.
Yeah, sure, correct.
All right, huh? Okay, so what's the value again? Sorry.
17.9.
17.9. Okay, once I get this current 17.9 ampere, single phase, I remember that. What do I do next? What do I do
Multiply
next?
by 2.5, right?
Why? Why multiply by 2.5? Lester. Why multiply by 2.5? Is it required to multiply? When do we multiply by 2.5?
When we have a starter.
I think we multiply when there's a load, right? Is it to a start?
When there is a starter. So remember, this one got no starter, DBA. DBA is just a general type of circuit. So I don't need. So I need to calculate IB. So this is my second step. Now for this, because it is a non-motor load, my IB is the same as my I full load. So it's equals to 17.9 ampere. Single phase. Okay. So you notice, this is my step 1. This is my step 2. So now I find IN1. IN1 must be greater or equals to IB, the value. So if my IB is the same as my I full load and is 17.9 ampere, what should be the value I choose for the circuit breaker rating of IN1? What is the value I can choose for IN1? Anybody? Okay, I calculated I full load is 17.9 ampere. My IB also 17.9 ampere now. So what is the circuit breaker rating IN1 I can choose?
Or the next highest, right?
Yeah, so if you're not sure, you go back to any data sheet. Any data sheet will tell you what are the range of circuit breaker available. So if I go to a data sheet, maybe I just pull out a data sheet or somewhere. Okay, I can pull out this data sheet reference. If you turn to your data sheet, you go to any of these circuit breaker time current curve, right? Can you see all the number here? You can see this number. So just now 17.9 ampere, right? So which circuit breaker should I choose?
20 amp.
Thank you. Right? So I can choose here 20 ampere. 20 ampere rating. And then because this is single phase, I choose SPN, single pole neutral MCB.
Check, one question to ask you. So this, the first circuit, right, we take the efficiency as 1, right? Correct?
Correct. That's why I
Because
don't have
it's the
to.
motor load, right?
No, this is not motor load. This one, remember, DBA can be our lighting circuit, can be our general power circuit. This is not a motor load.
Also, we take the efficiency as 100%, right?
It's already computed. Actually, it's already computed inside here. So I as far as I'm concerned, for calculation purposes, I just use 1. That's why I never write anything there. Okay.
Oh, understood.
Okay. So that is the first circuit. Then I come to the second circuit. What happened? Can I do the same method? Can I do the same method? Step 1 like this, step 2 like this, and then step 3 like this? Cannot. Cannot.
We need to multiply by... Wait.
What is missing in the second circuit now? What is missing in the second circuit? What is no? That means there is some information missing. That's why I cannot do anything.
Power.
Yeah, the power is missing. Right, the power. Without the power, I cannot do. So I need to do an extra step. I need to do an extra step. So I will come back to this circuit later. Circuit 2, we come back later. So this one KIV for a while. I have to do something first before I can do the calculation. Right? Then let's go on to circuit number 3 and number 4. Now, number 3 and number 4, because the motor, everything is the same, right? So whatever I calculate in number 3, I can apply exactly the same for number 4. Okay, so that is something good about circuit 3 and 4. They are both the same. Who else is here? Jingyi, are you here?
Yes.
Okay, Jingyi, now is your chance to do your calculation. How to find the value of IN3?
22,000 over square root 3.
Okay, don't just say 22,000 something. When you do
Okay.
a test paper or exam, right? Always make sure you write the formula out first. Okay?
Okay.
That means I write the formula. I full load equals to what?
Load over
Not load, power.
power.
Power over
Square root 3 times V times power factor times efficiency.
now this V is a different V. This is the line to line V.
Yeah.
What's here is the line to phase. This is the phase voltage. Multiply by efficiency and power factor, the same as the earlier formula. So as I said earlier on, please always write the formula out first. Okay? You write the formula out in case when you do your calculation something wrong, at least you get some marks for your formula. So I have 22,000 watt divided by root 3 times 400 volt, because it's 3 phase, times 0.8 times 0.83. So give me your answer. These two are the same, this I full load and this I full load, because they are the same circuit. Come on, the rest of you can take out a calculator and quickly give your answer now.
47.82.
47.82 ampere. How many single phase or 3 phase?
3 phase.
3 phase. So write it down. Okay, write it down to remind yourself I'm dealing with single phase or 3 phase. Okay, so that is the first step. What is the second step? So this is the first step. What is the second step then?
You must find out what starter is using, right?
So what starter am I using here?
Star delta.
Okay, star delta starter. So now I know it's a star delta starter. Then what happened? Remember,
Then you multiply by 2.5, right?
what multiply? Must write down. Cannot just say like that. That means I need to calculate what? I need to calculate the design current, IB. IB is 2 times I full load. What's the reason? Star delta starter used. Okay, all this must write down, when you do your calculation. Okay. That means this is step number 2. Step number 2. So if I do the calculation, what is the value in ampere? Okay, the rest of you can quickly help or not. Take calculator out and give me the answer so that we can move very fast. You don't have to keep on calling out names, right? Gordon, are you here, Gordon? Hello, Gordon, are you here? No, okay, still considered absent. What about Muhammad Faizal? What is the answer to this now? IB equals to what? Joshua, are you here, Joshua? Hello?
Yes, sure.
What's the answer for this one, IB?
I can't lie, sure, but I don't really know.
Hey, the formula already written in front of you, friend.
I wasn't focusing, sure. I'm sorry.
2 times I full load. Just now,
Sure.
Ting already calculated I full load. Who is that?
Sure, 95.65.
95.65. Thank you. Nadia, is it?
Yeah.
95.65 ampere. 3-phase or single phase?
3-phase.
3-phase, sure.
3-phase. Remember, our this circuit is all 3-phase. So now I done the second step. What is my final step? Anybody?
The breaker, is it?
Yeah, now I can find the value of my breaker. IN3 will be what? How much?
100.
100 ampere. Thank you. Right? Because I have 90 ampere. Now this is 3-phase, so I can say TP MCB. Get the idea or not? That means my step 3 is I just use IB must be greater or equals to, IN must be, IN must be greater or equals to IB. Therefore, I select IN equals to 100 ampere TP MCB. So you notice, since the first circuit, I'm using this 3-step all the time. I full load, IB, IN. I full load, IB, IN. So this is also the same because the same type of circuit. So this is also 100 amps. TP MCB. So now I have the answer for circuit number 1, circuit number 3, and circuit number 4. Okay. Anybody has any questions? Sorry, this one is okay. 3-phase, 3-phase, so it's TP. Anybody have any question to clarify about circuit, how the circuit number 3 and circuit number 4 calculation is? I cannot see. Where are you? Okay, so no question. So I have settled circuit number 1, circuit number 3, and circuit number 4. Right, I'm running out of space, so what I'm going to do is I'm going to duplicate this, and I'm going to delete some of the calculations so that I can move on. Right, so now I can take off all this calculation. I already got the answer. IN1 is 20 ampere, IN3 is 100 ampere, IN4 is 100 ampere, okay? So I'm going to take away, delete all this so that I can have all this can take away. So you notice that the method, the 3 steps always the same, but it's just I need to know whether it's a motor circuit or non-motor circuit, and the way I calculate is different. I'm going to clean up this so that I can have more space to do the calculations for the other part. Anyone got any question? Please ask. Don't just keep quiet and then later on don't know how to do. Okay. So now I have answer for 3 circuit already. Now let's go to circuit number 5. Now this time I need somebody to take on the challenge and do it all the way. Who want to try? Joshua, I'd like you try how to size circuit IN5.
You use the same formula that you always use, right? You
Okay,
find
what's the formula? Tell me the formula.
the IFL1, right?
Okay, let's start with IFL1.
So
IFL1, the formula first. Always give me the formula first.
the watts, the 7.5K watts.
No. Write the formula out first. Power.
The power over square root 3
root 3
times the voltage.
Voltage, line voltage,
Yep, times power factor times efficiency.
Time efficiency. Okay, so please write this formula out first. Then
Yes.
in the value 7500 watt divided by root 3. What is the VL?
Your VL 400.
400 volt multiplied
Yes, sir. By 0.78.
0.78 multiplied by
0.88.
0.88. So what is the current? Take out your calculator and give me the answer.
I lent my calculator to my brother, so I don't have nausea. PS.
Your handphone can calculate lah, friend.
Then how to do square root 3 on my handphone?
Okay, then call for help lah. There's so many people.
I call Gregory for help.
Okay, Gregory, please give the answer. Gregory not around,
Oh, then I call Ethan for help. Ethan.
Ethan. You kena error, Ethan.
Yes.
What's the answer?
Yeah. I think it's 15.77.
You think only
Yeah. Mental sum.
Anybody? Mental sum. You're so good at doing mental sum. Anybody want to challenge this answer? Come on. Lester, your calculator, take out, please. Gregory not around, Joven not around. Ryan, what is your answer, Ryan? Ryan. Faisal, are you back, Faisal?
Yeah,
What is your answer for this one?
same as
Correct.
15.77 ampere.
Right, Okay.
Yes, the answer correct.
Okay, Josh, what is next? After I do the first step already.
What? Me again?
Of course, you're supposed to find the answer IN5
Oh, then you
What's the next step?
the what? Something I forgot the first one. Something equals 2 times IFL, is it? That one.
Design current. Come on, design current is how much? IB equals to what?
Oh, 2 times IFL.
Why 2 times? Is it correct or not?
Yes.
Wrong.
Why?
Because it's what kind of starter?
DOL.
Oh.
DOL starter is 2.5. So what is the answer? Don't have a calculator. You arrow.
Wait, I mental calculation. Wait, give me 1 second.
Okay, you can mental or not?
Can, of course.
Okay.
Come on.
The rest of you can work faster than Joshua.
Wait, no, I don't need help. I don't need help.
Yeah, some more. Yeah, papaya.
39 point something. 39 point. 39.42 something. 42 something. 425 or whatever. I don't know.
Single phase or 3 phase?
3 phase.
Three-phase, okay. Who can double confirm correct or not?
It's correct. It's correct.
Correct.
Sheesh.
So that is the second step. So what is the final step, Joshua?
You must find the MCB.
That means I can select my IN 5,
Yeah.
be greater or equals to this IB value.
So 50. No, not 50. 40. 40
40 ampere
TP
TP
MCB.
MCB, yes. Now
Can.
that's the value. All right, so that is the value for this guy. This one is 40 ampere TP MCB. Wow, I literally doing PBL 2.2 for you all. If the lecturer know I do that, they'll kill me. Supposed to be done by you all. All right, who wants to help me finish the last circuit? Lester, would you want to help me? You already done the first one already. Lester was the one who gave me this answer already. Who wants to do the last one? Nadia, you want to do the last one, Nadia? Nadia, are you around?
Yep, sure.
Okay, what is the first thing I need to do in order to find IN6?
Find IFL.
IFL again, okay? So I shall write here. IFL, what is the formula?
Power over voltage times power factor times efficiency.
Okay, so I put in the numbers. 1500 watt divided by how many watt?
230.
230. Why?
Cause single phase.
Single phase. Okay, power factor 0.85, and then the efficiency 0.9. So what is my value for IFL?
8.53.
8.53 ampere. Single
Yeah.
phase or three phase?
Single phase.
Single phase, Therefore, now my IB equals to what?
IB equals to 2.5 times IFL.
Times I full load,
Yeah.
So tell people why. DOL starter used. Okay,
Okay.
so how much is that value?
21.31.
21.31 ampere single phase. Okay. And now I can find my IN6 already. IN6 must be greater or equals to IB. So I select IN6 to be what?
25, I think.
25 ampere.
Yeah.
25 ampere what?
TP-MCB or is it SPN? I'm confused with that.
Now it's single phase, Single
Oh,
phase.
okay. So
SP,
SPN, is it?
yes.
Yeah. SPN MCB.
Okay, very good. All right. So now I have the circuit breaker rating of IN1, IN3, IN4, IN5, and IN6. So there's only one missing. Anybody can suggest how to tackle circuit number 2? How to handle circuit number 2? Because
We add everything up together, right?
yeah, but I cannot add up because I have, what do you mean by add up?
Like all the other powers.
Yeah, but I cannot add up because my circuit number 2, the power I don't have. How to find that one?
I think we find IN, right?
How to find IN for circuit number 2? Anybody got any suggestion or?
Oh, you can calculate the power from the lighting, but
Okay, we have to do something. We have to do a load balancing. I know you all have not done that part in the lecture, but I will show you how to do. Let me clean up all the others first. So now I have already, all this I can write down first. I have this one is 25 ampere, SPN, MCB, okay? So I can clean up all my calculations so that I can focus on the last part. Later on, maybe I will send you all these slides so y'all can use it as a reference. All right, now what's happening is that I have one circuit. I'm not able to complete my calculation because I don't have the power. So for DBB, I have to do one more step. I have to do what we call load balancing. Right? In fact, not only now, DBB, we do load balancing, we find the load, and then we can calculate. So like this one already given to you. Given to you is because somebody went to do the calculation. But here, we haven't do the calculation, so I need to do one step. I need to do this calculation first. Then I can do my IB and then IN, okay, to complete this part of the calculation. Because if I don't complete this part of the calculation, then I cannot finish my single line drawing, right? After I finish calculating all here, then I can calculate this guy. Okay? So I'm going to zoom in on this DBB. Now, what is the challenge for DBB? Let me create a new slide. Now, DBB is actually a three-phase. All right, I'm going to take the information from the I'm going to take the information from the let's see. Okay, I'm going to take the information from here. There is the information provided for me here, and I must use this information, otherwise I can never calculate. Now, this information is the information that I want. So let me screenshot this. Let me screenshot this. Then I transfer this information there. Then we can use that one to work out. Screenshot first. Just one certain part. I only want this particular information, so I take this information out. Okay, then I'm going to transfer to this so I can use this for my calculation. Now this DBB, because it comprises of many circuits inside there. So I need to slowly do the load balancing here, because this DBB is a three-phase. If you read the instruction carefully, it's three-phase. Three-phase means what? Three-phase means if I were to draw this single line diagram, it will look, it's a miniature of the one we are looking at. This one got 27 way going out. 27 way. Right? 9 by 3 is 27. That means each phase L1, L2, L3, I have 9 circuits. Right? So I need to do a load balancing. Otherwise, my circuit will be very, what we call not balanced. So I need to find the balancing act. Now, this is the time I want you all to make use of the notes. In the lecture notes, you always draw tables like this. So you must master the idea of how to draw tables like this. I'm going to show you in the lecture notes. Lecture note, if I go to this one, right, you see that we draw a lot of tables all the time. Can you see? We're always drawing tables. The reason for that is we want to be able to visually see how are we going to distribute the circuit. So you see, keep on drawing. So once I draw this circuit, then I can finish drawing this diagram, right? So this is what we call the load balancing table. So in this example, I'm going to do the same, all right? That means I need to do load balancing. How do I do load balancing? I start by having 3 columns, L1, L2, and L3 phase. Then I look at each of the circuit. For example, this one says I have 8 numbers of 10 amps lighting circuit. That means I have all lumped together, I have 8 circuits now. So how do I split the circuit? Lighting circuit, how do I split the circuit? So if I were to write down lighting circuit number 1, lighting circuit number 2, lighting circuit number 3, lighting circuit number 4, number 5, number 6, number 7, and number 8. All right. So each of this circuit, the load is the same. So all I need to do is calculate 1I full load. Each of the circuit has how many lighting? 20 numbers of 40 watt fluorescent lamp. Right? So 20 numbers times 40 watt multiplied by 1.8. Because there's no other information given, divide by 230 volt. So this will give me the full load current for one circuit. So do a quick calculation. What do I get? 20 times 40 times 1.8 divided by 230 volt. I get 6.26 ampere. All right, so what happened now is that if I want to do a proper load balancing, all I need to do is assign each circuit according to this. First circuit, I will put the load in phase number 1. Second circuit, I put in phase number 2. Okay, I put in phase number 2. Third circuit, I put in phase number 3. Fourth circuit, I go back to phase number 1, phase number 2, phase number 3. So I got 1, 2, 3, 4, 5, 6 circuit already. 7 circuit, then 8 circuit. Now all these, I need to apply diversity factor. Now diversity factor for this one, because it is a factory, I'm using 0.9. Anybody know where I get my 0.9 from? Anybody know where my 0.9 come from? Is there anybody out there? I must call names again. Hey, Ryan, are you there, Ryan? Hello, Ryan? Link copy area. Yet Hong, are you around, Yet Hong? Not around. Chingy. Chingy, are you around?
Here.
Where does the 0.9 come from?
The maximum demand, is it?
No, 0.9. Where does this number 0.9 come from?
Oh, wait. I got no idea.
No idea. Come from the table DF. Where is the table DF?
Oh, the maximum demand, right?
Yeah, maximum demand table.
For the stores.
Our data sheet, you know where, right?
Yeah.
Okay. Because this is shops, so we use 0.9. Okay, so this is the lighting circuit. Now, in addition to the lighting circuit, I also have 17 numbers of SSO circuit. Now becomes a challenge, right? 17 numbers means this one is lighting circuit. Come to the SSO circuit. I have 17 of them. So if I were to distribute over 3 phase, right? I have to do 17 times. So I need to do a very quick shot. So what I do now is from P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12, and carry on. P13, P14, 15, 16, and then P17. All right. So if I were to assign the load, how should I align it so that I try to balance the load? Before that, I just calculate the I full load for each circuit first. Now, for this case, because this information is given, 350 watts per SSO. So I use this method to calculate the I full load. So I have how many SSO per circuit? I got 4 numbers. So 4 times 350 watts divided by 230 volt multiplied by power factor 0.85. So this will give me how many ampere? 4 times 350 watts divided by 230 volt divided by 0.85. So it give me 7.16 ampere single phase. Okay, this one also single phase. So now I have to do load balancing, means I try to find a way to assign the circuit in such a way my total maximum demand will be the best I can balance. Okay, that means if I go down a bit further, right, so what I do, you see currently what happened based on lighting, I have 3 circuit, and 2 circuit, right? So this time I will start from here. I will start with 7.16 ampere here. Then I go back to here, 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 7.16, 7.16, 7.16, like that, all the way. This one look very tedious, right? But I have a quick way out, a lazy way out. So what is a lazy way out? Can you count how many circuits will be in each of these or not? You can, right? And so on and so on. So basically, this one, the diversity factor is 100% already. So now I have to just tally up all this. What is the total for each one of these phase? Okay. So this is how I will do my maximum demand calculation, because at the end of the day, I need this for my main calculation. So what I do now is, let me see. Oh, cannot. Okay, so now what I do is I try to find a way to add up everyone. So if I look at phase L1, phase L1, the maximum demand will be what? 6.26. How many circuits are there? 1, 2, 3. So 3 times 6.26 ampere multiplied by the diversity factor 0.9. So this is for the lighting part. Plus, how many SSO circuit would I be having here? Anyone can tell me or not? Because there are total 17 of them, right? 17 circuits altogether. There's the 17 circuit. Yeah, 17 circuit. So 17 circuit, if I start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I end up 17 here. That means this one and this one will have one more circuit. So I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 here. Right? So here I have 1, 2, 3, 4, 5, 6. 6 times 7.16 ampere. Since the diversity factor is 1, I just multiply by 1. So this is my total maximum demand for phase L1. Okay, who has a calculator with you? Can you quickly calculate for me what is the value? What's the value? Hello? Anyone got a calculator out there? It's funny that everybody, I got to call your name. Hello? Suzairi? Are you there?
Yeah,
Suzairi?
wait, give me a sec. 59.862.
59.
0.862.
862. Okay. Okay, that is for L1 phase. For L1 phase. Now, L1 phase is the same as this one also got 1, 2, 3, 4, 5, 6, right? So here 6, here 6. Then here only got 5. 1, 2, 3, 4, 5. Right? So the L1 phase is the same as the L3 phase because they have the same number of circuits. So I don't need to do a second calculation for that. Now I come to the phase L2. Phase L2 will be how much? This time I have also 3. Oh, sorry, it's different. L3 here got only 2 circuits, so the value is not the same. So I need to do another calculation. Okay, I'm running out of space here. Okay, so what should I do? Let me find a smarter way. Right outside here. Okay, let's see whether I can. No, I can't write outside here. So I can't write outside here. So what I can do is I just remember what I have done. Okay, I have to toggle a bit. I'm going to create another table, another slide, and I'm going to do the calculation here. Okay, I'm going to repeat here. IMD1. I maximum demand for phase 1, phase L1. We have already calculated here. Is 59.86. Okay. Right now, IMD for phase L2 is equals to lighting. I have 3 circuits. So lighting, I will write 3 circuits. So it's 3 times 6.2, 6.26, 6.26 times 0.9 plus the P circuit. I have 1, 2, 3, 4, 5, 7.16 times 5. 5 times 7.16 times 1.0. So that will give me the maximum demand for phase L2. Then the last one, I maximum demand for phase L3 will be 2 times only this one. 6.26 times 0.9. But this time, this one, I still have 6 circuit here. 6 times 7.16 times 1.0. Okay, who have a calculator, please provide me the answer here. Okay, anyone who has the calculator, please provide me the answer.
Sure, 133.
Which one?
The L2.
L2 is how much?
133.
133, so high. Something,
Yeah.
something wrong. Calculate again.
52.70.
52.70.
0.
Okay, Nadia, check again. And the other one?
Oh yeah, it's 52.70, yeah.
Yeah. So let's do the last one.
54.23.
54.23. Okay. So now what happened? You see, you notice that even though we try to balance the load, right? But no matter how we balance, this is the best we can get, right? So therefore, as far as I'm concerned, I choose the one which is the highest, which is this one. Therefore, I will say the maximum demand for DBB is 59.86 ampere, 3-phase. Even though the other 2-phase is less, we don't care. Right?
Okay, so is this voltage acceptable or not? If let's say in a power system.
Sorry, Lester, I missed your last part.
So is this current acceptable or not? If let's say we measure like this in a power system.
Yeah.
So it's like that is acceptable, right? Correct.
Even though it's not balanced, but at least it's close because they are all like quite distributed out.
Oh, so it depends on the type of load for each line, right? Correct.
Yes, correct. Because the individual circuit, they got different load, so I cannot put all together. And then the circuit is not like divided by 3, right? So you notice, like in the L3, I only have 2 lighting circuit. I can't have more because don't have already. So this is the best I can do. Okay. So if I get this, then what happens is that if I want to convert it to power, therefore the power in kilowatt, because this one later I need to write back there. Power is equals to what? Voltage. In this case, we are talking about 3-phase. So it's √3 times 400 volt times 59.86 ampere. This will give me kVA. Not in kilowatt yet. If I want it in kilowatt, I need to convert using a power factor. Therefore, the power for this board is how many kVA? Can you give me the number? √3 times 400 volt times 59.86 ampere. How many kVA is this? Anybody can be faster than me?
$41.5.
41.47. Don't round up so fast. 0.47 kilo kVA. Okay. So if I want this in power in kilowatt, I need to use a power factor. Because power factor is kilowatt over kVA. Therefore, if I want to know the power in kilowatt, I assume a power factor first. That means this power in VA, multiplied by the power factor. So that will be 41.47 times 0.85. That will give me the power in kilowatt. So it's 41.47 times 0.85. That will be 35.25 kilowatt. So that's the power. Okay, so now with all this information, now I'm ready to go back and finish the calculation for this one. Okay. Anybody has any question to clarify with me? Right, so now with this calculation, I can now go back. Okay, I take the information from here. With this calculation, I can now go back to this original calculation. I can now fill in the blank here now. Okay, so now I'm ready to do my I full load here. So what is my I full load now? My I full load is the same as my I maximum demand. So how many amps is that? 59.86 ampere. Three phase. Okay. So that's how I can now continue with this one. So if my I full load is this, what is my IB? Equals to what? Joshua, this one I need you to come in again, Joshua.
So you call me again?
Yeah.
What's up?
I need your help. Now this circuit, IN2, what is my IB?
You find the IB.
We calculated the I maximum demand already. So now what is my IB?
This is one phase, right?
Is it one phase? Look carefully.
Three phase times.
What's my IB now?
It's on times 2 again, or I don't know.
Why you times 2? Hey, are you with me or not? Is this a motor load now?
Oh no, it's not.
It's not. So it's the same as the first circuit, right?
Yeah.
So first circuit means what? IB is equals to my I full load. Because it is a non-motor load.
Non-motor load.
So it is the same as
59.86.
59.86 ampere. Hey, you come in and out like this is a what? So are you not following? Then what is my last step?
Your last one, this one you select the MCB, right?
So how do I select the value for IN2?
Is it
what should I choose for IN2? IN2 equals to what?
more than or equal to the IB?
Yes, very good. You're remembering now. So 59.86 amps. So what should be my answer for IN2?
63.
Yes, because that's the only available.
Yeah, I don't have 60.
So 63 amp, what? How many pole?
Three phase. So it's this one TP also.
Can it be TP or not? Is this a motor load?
No, it is not.
It's not. So it must be what?
TPN.
TPN. Ui.
Oi.
You think like lucky draw like that. So this is step number 1, step number 2, step number 3. Okay?
Yep.
So now, yay, we completed all our outgoing circuit calculation. I hope every one of you know how to do this, because I can guarantee you in exam, in a test, you are asked to calculate this many times over and over again. So now I have finished calculating all the circuit breaker rating for the outgoing circuit, from circuit number 1 to number 6. Anybody has any question about what I have been spending time on talking to you? In fact, are you all here or not? Okay, let me do a attendance check again. I'm going to call everybody's name. Lester, are you here?
Yes, sir.
Okay, good. Isa, are you here? No, 0.
Yes,
You are here. Why you never make noise?
I've been here.
You've been here. Otherwise, I will call you to do. What happened to you, Isa? Why are you late?
My laptop crashed.
Your laptop crashed. Time to get a new laptop. Okay.
Yeah,
Get
sure.
free.
You're gonna buy for me, right?
I cannot buy for you lah. Your laptop so expensive. Laptop crash, you better get ready because next week the test, you need a laptop.
Okay.
Your laptop crash during the test, then good luck to you. Gregory, are you here, Gregory? Gregory is not here. Jeff, are you here, Jeff? Okay, Jeff.
They're not here. I don't know where is Jeff.
Who are you?
I also don't know who I am.
Okay, 0.
Hey,
Joven,
I'm here.
who are you?
Jeff lah.
You are Jeff. Okay. Joven, are you here, Joven? Joven is clearly not here. Ryan, are you here, Ryan?
Yes, sure, I'm here.
Okay, Ryan is here. Joshua, are you here?
Of course, sure. Of course, I'm here.
Of course. You go and drink kopi, then come back. Noma
Yes,
Faizal. Noma Faizal, are you here?
Yes.
Faizal is here, but never talk. Suzairi, are you here?
Yeah.
Nadia, are you here?
Yes, sure.
Yongkang, are you here?
Yeah, I'm here.
Right here. You've been very silent. I mark you absent.
Oh, I didn't hear you call me.
I call you many times. Nuafini, are you here? Nuafini is not here. Ong Boon Hai, are you here? Ong Boon Hai is not here. Tan Jing Yi, are you here?
Yeah.
Terence Shai, are you here? No. Wang Sihan, are you here? Wang Sihan, are you here? No. Ethan Wong, are you here?
Yeah, I'm here.
Okay. Yong Yet Hong, are you here? Yong Yet Hong, are you here? No, Okay, this is all recorded. You have no response means you are absent. All right, now I want to spend the remaining time. Now we are already 3:35, not much time left. In order to complete this single line, I need to finish up the last part. All right, the last part is how to calculate this design current here. Notice I give a prime because this prime tells me it's about the sub-main circuit. Now the problem is because this circuit comes in here, but it's split into so many loads. So how do I determine what is a reasonable IB? Okay, so we have to use the formula given in the notes. I'm going to point to you the formula in the notes so that you can remember. Now, the formula in the notes shows like that. Okay, all this the lecturer haven't covered, but the example is important. So how do I size the circuit breaker when I have outgoing circuit and incoming with a mixture? So I want to point to you the okay, sorry, this should not be. I should be looking at the topic 3. Okay, let me open it up. Actually, topic 3 we already covered this. I look at the topic 3 lecture note. Topic 3. All right, when we have a dB with all the different combination of load, I must use a certain formula. So how do I use that formula is outlined in this notes here. Okay, you notice if you go to this example, you go to page lecture note page T25. Now page T25 give you a method of how to size this load. Okay, it says the design current at this point can be calculated using this formula. So I'm going to use this approach to apply to our PBL 2.2. Okay, that means the IB at this point is calculated using IN1. What is IN1? IN1 means the circuit breaker rating of the largest motor circuit. Instead of taking the I full load here, I take this one, this value. Then after that, I take all the I full load or maximum demand value with any diversity factor implied. Then once I calculate this value, then I use the same formula that we've been using all the time to decide what should be the rating of this guy. Okay, so if you are not sure where I take the theory from, I take the theory from this page, page T3-25. Okay, so I'm going to go back to the calculation to finish up what we are doing today. All right, so in order to do that, what I'm going to do is I'm going to I'm going to clean up this one. So I'm going to duplicate this one. I'm going to take out all this first because I need the space here. Okay, so now what I need to do is I need to calculate IB prime here at this point so that I can decide this one. So IB prime, according to just now the guideline, IN1 of the largest motor circuit plus sum of the I maximum demand or full load of the other circuit. Okay, so that is the guideline given to me. So if I put that into numbers, which of this circuit is the largest motor circuit? Anybody can tell me? Is it circuit number 1, number 2, number 3, number 4, or number 5, or number 6? Hello? Anybody here? Are you with me? Nobody can tell me, so I must call out names again.
3 and 4.
Circuit 3 and 4. Okay, circuit 3 and 4 are the biggest, right? So all I need to do is just take one of them. So I take circuit 3, okay? Circuit 3 means I take 100 ampere. Then I add all the rest. Now the problem with the rest is that because I got some single phase, I got some three phase. So I need to do a load balancing at this level. Then I can decide what is the single phase to take. Huh? So before I can apply this formula, I need to do one more step first. I need to physically assign for circuit 1 to 6, how I am going to do the load distribution. So in other words, I have to do one more load balancing table. So I'm going to use this table. Okay, I'm going to create a table like this. I'm going to create a table. Okay, I don't like this one. So what I'm going to do is I'm going to get into a new slide. It's easier to see. So I'm going to start a new slide. I need to toggle in between, unfortunately. Right, I need to do a load balancing at this level. That means now I must draw a load balancing table so that I can decide how to calculate IB. All right, like just now the DBB, I need to do this. So I start by saying I create a table L1, L2, L3, right? And then because I have 6 circuits, right? So I create, I insert another 2 rows. Oh, I can insert. Here's my insert table. Okay, I insert 1, 2, 4, 5. I insert one more. Let's insert. What happened to my insert button? Okay, so I insert the circuit. I have 6 circuits, so I have to write down all the circuit here. So in other words, I'm doing a final load balancing. Right, I need to do this calculation. So what I do now is circuit number 1. Circuit number 1, is it single phase or 3 phase? Single phase, right? So single phase means I have to, so my DBA, I can only put the load in one of the phase. So which phase should I put? Earlier on, we calculate the current. The current was how much? 17.9 ampere. So now I come here, I put 17.9 ampere, let's say in this phase. Okay, because this is single phase. Now there's a nice table in the PBL 2.2. Actually, I should be using that one, but since I drawn here, I will continue. So this is circuit number 1. Circuit number 2 is 3 phase. DBB is 3 phase. So 3 phase means I can transfer the values from the earlier calculation here, 52.7, 54.23, and 59.86, right? So I transfer this here, 59.86, 52.7, 59.86. Now I won't put 59.86, so I put 59.86. Oh, cannot, because I use the When I do the calculation, I already decided which phase to use. So this one should be here. This one should be at this point already. 59.86. So 59.86 here. I already decided earlier 52.7. So 52.7. 52.7. And then 54.23. 54.23 here. All right, then come to circuit number 3, circuit number 4, circuit number 5, and circuit number 6. I take the values from all this calculation. Okay, circuit number 3, when we calculated, circuit number 3, circuit number 3 is circuit number 3, I full load. What was our calculation? Circuit number 3, I full load. Okay, here, no, sorry. So, here, I full load is 47.82. Okay, so I transfer here 47.82, 47.82, 47.82. This one is for the what motor is this? So this one motor circuit. This one also motor circuit. And both are the same, right? So I should write here 47.82, 47.82 all the way. And finally, my circuit number 5. Circuit number 5 calculation was done where? Circuit number 5 is 3-phase also. 3-phase is 15.77. This one is an air compressor. And the last one is single phase. Single phase, what was the current? Single phase, 8.53 by single phase. So single phase, I only need to put in one of the phase, 8.53. 8.53. Since I already have a single phase here, I'll put here 8.53. Okay, so this one is a molding machine, I think. Okay. So basically what I have done is that I have done a load balancing table. So in PBL 2.2, you need to have this table. SSB. Right, now once I have this table, diversity, I don't have to apply because I'm not given any diversity. If I want to apply, this is the diversity I will use. 100%, 80%. Okay, diversity factors. This one no need already, applied already. So this one I will use 100%. I will use 100%. This one I will use 100% because only got one circuit. This one also I will use 100%. So now I can find my total maximum demand. So how do I find my total maximum demand? Okay, total maximum demand. How to find total maximum demand? Each column, I add up, multiply by whatever diversity factor, I get the 3 values here. Can you all help me? Everybody? Do the calculation for me and give me the answer. Everybody? I'm going to drink my water for a while. If you have the number, please call out what is the L1 number. Come on, everybody, use your calculator, please. Who is going to give me the first L1 total maximum demand? Hello? Is there anybody out there? Ryan, I'm going to depend on you. Can you give me the answer for L1? Jeff, you give me the answer for L2, Jeff. And Sihan, are you back, Sihan? No. Ethan, you give me the answer for L3.
Archer L1
Ah,
189.17.
189.17
17.
ampere. Okay, thank you.
163.076.
Which one?
L2.
163.076.
076.
Okay. And the last one?
165.64.
Huh?
165.
165.64
64.
ampere. You're including the diversity factor already. Okay, so now what happened is I have three values. They are not 100% exactly the same, but that's okay. As far as I'm concerned, I only zoom in on the largest value. So in this case, it is the 189 ampere. Therefore, I must make a declaration. Now, what is my declaration? My declaration is, let me start a new one. My declaration is that my maximum demand for the whole switchboard. So these are the steps that you must do. Every time you do load balancing, you must declare. After all the calculation ready, right? After all this calculation here, I must declare. I must tell people the maximum demand for this sub switchboard, because we call this sub switchboard, so therefore I'm going to use the same term, or sometime in bracket we say SSB is, I look at the tree, I zoom in on the highest value, 189.17. 189.17 ampere, three phase. Okay, this statement is very important because this statement, as I mentioned earlier, is we declare this to the power supply authority. As far as they are concerned, they assume all three phases are balanced. So they will work to supply us this amount of electricity. All right. Anybody have any question about how I do this load balancing? Anybody got any question about how I do this load balancing? Okay, so I add up this way. Now notice that because I am declaring the L1 as the main phase, then now when I come to do this calculation, I only look at the L1 phase. I repeat, I only look at the L1 phase. So I'm going to copy this and bring it down to the other side. Now I do my load balancing already. I want to calculate IB using this formula But I know that I'm zooming in on L1 phase only. So the other phase, I don't care. In other words, you notice that in my L1 phase, this circuit is not counted inside. It's okay, but I count this one. Okay, so this circuit is not in the calculation, because it's not inside this L1 phase. So I come to this one, how to apply this value. I zoom in on the L1 phase only. Okay, so I'm going to use L1 phase to calculate this one. So if I follow that, right, I go back to the table. Which one is the motor circuit? Just now we say circuit 3 and circuit 4, right? So I take, because the two of them are the same, so I assume one of the circuit is the largest. I take the circuit breaker rating of the largest. So I take 100 ampere from there. Okay, from here, the circuit breaker rating plus the maximum demand of the other circuit. So what is the maximum demand of the other circuit? This one. Notice that this one times 0.8. So I have to take 47.82 times 0.8. So 47.82 times 0.8 plus 17.9 plus, sorry, I have to do over 3, plus 59.86 plus the last circuit 15.77. So can someone add up for me how many amps is this? Can someone add up for me how many amps is this? Yongkang, are you here, Yongkang?
Yeah.
Can you give me the answer for this?
Yeah.
What's the answer?
207.8.
207.8. Correct. 32, 42, 49, 50, 109. I think more than that. Can somebody else do the calculation? Come on, everybody. If you all don't help out, it's very slow. Please help out, please. Please check whether the answer is correct.
231.79.
231.79 ampere, 3 phase. So who is correct now? We got 2 answers here. Anybody else can double confirm which one is correct? Where is Joshua? Joshua go home already. Can I mark him absent? Joshua, are you here, Joshua? Joshua go home already. Okay, go home then. Bye-bye. 231.786. Okay, so 231.79 is the correct answer. I'm wrong, huh? Kang, your calculator got the chain, You change your calculator.
Oh no, I press wrongly.
Press wrongly. Okay, so what happened now is that my IB prime is 231.79. Then what should be my IN? IN must be greater or equals to IB prime, right? So what is a suitable value for me to choose? 231.79. Now, in exam or test, right, you go to the first page of the exam paper. Usually they will give you the range, how many ampere is available, things like that. So let me see whether I can pull one example out. Okay, unfortunately, I don't have an example sitting here. Now, if you go to mail, whenever you're not sure, right, you go to mail, you go to you go to mail, and you go to any of the past year exam paper. Usually, if you take it out, you will see that the first page is always the page that gives you the what are the range. Alamak, this one goes to the library. Let's look at this one. All right, can you see in front here, they always publish this one. What are the range? So if my calculation, just now my calculation is 231.79, right? So 231.79, my next circuit breaker I can use is 250. Can see that? Because the other one is only 200. So I will choose 250 for as my circuit breaker. 250 ampere. Now incoming is three phase. So three phase means I use either TPN or 4-pole. MCCB. MCCB. Because there is no circuit breaker that is so high value. In other words, at this point here, now I have completed my calculation. I got enough information now to draw my single line diagram. Maybe I choose 4-pole for this one. MCCB. Okay. So what I have just shared with you this afternoon is the detailed calculation from the starting point when we first draw out this single line diagram, do all the individual calculation to get all the answers, right? Until I finally get every values. Now I'm ready to draw my single line diagram. Yeah. Anybody have any question to ask me? Things that I write down, but you don't know why I write the one.
Can we choose a lower breaker or not? If let's say we like so we just choose the next highest, right? If let's say the number not there, so we choose the next highest, right?
Yeah, we have to choose the next highest. We cannot choose the next lowest. You know why? What is the meaning when I choose the next lowest? Let's say, for example, this one, my current coming in is going to 231 ampere. I go and choose 200 here. Then what happened? Somewhere in my operation of this switchboard, right, is going to trip, right? Because the current will be overload.
Can be overload or anything, right? So if we choose the next lowest, then we'll have more like tripping, right?
Yeah, then somebody's going to scold me, right? So I cannot choose the lower. I must choose the higher one.
Okay.
Yeah.
But what if let's say we check the numbers and then they don't have it there, like on the
Choose the next higher up. Like just now I was saying, right? If I go to the mail, the exam paper, you see that the one range is 250, then after that is 200, then it's 250 already. So if I choose 200, I'm going to be in trouble, right? Agree? If I choose 200, right, somewhere in time while my circuit is being operated, right, it's going to trip because it will be overload.
Oh, so so no matter what number we get, just choose the next highest, right?
You have to choose the next highest, cannot choose the next lowest. Okay, this is very important. Cannot choose the wrong one.
So that means the numbers on the given in the paper, right, are the commonly used breaker rating, right?
Yes, correct. So you must look at the test paper or exam paper, right? Look at the front page there. The front page always give you the range.
Oh, so normally it will fall within that range, right? Correct. The answer that we found.
Yeah, it should be in this range because it's very, very big range.
Oh, okay.
And thank you for your question, Lester. Anybody else got any other question on how to do this calculation? So I have provided you with all the calculation from the first circuit to the final circuit already, to the sub-main.
Yeah.
Yes.
I don't understand how you get the IB, like the 47.8 times 0.8.
This one,
Yeah.
Okay. What happened is that if I go back to the table, you see this load balancing table, right? Load balancing table, actually, I supposed to apply the diversity factor. Can you see the diversity factor here?
Yeah.
The reason why all are 100% is because like this DBA, all this inside here, they already have the diversity factor built in. So that's why from here, I don't apply another diversity factor. That's why I use 100%. By DBB, I also use 100% because just now in our earlier calculation, the individual diversity factor already apply here. So at this level, I cannot double apply. Otherwise, it's going to be double counting.
Oh, no, but the 3 and 4, right, you merge them together.
No, 3 and 4, I don't merge. You must remember there are two different circuits.
Yeah.
So if I follow the diversity factor for this motor circuit, right? Now, where do I get this 100% and 80%? It actually come from the diversity factor table that we use every time. So where is my diversity factor table? Okay, let me open up our data sheet.
Oh, so the first one you use the rating of the breaker, then second one you use the 80% one.
Correct. That's why my calculation is like this.
Oh, okay.
So I take the circuit breaker rating of the first one already, right? So I don't count this 47.82. I take the circuit breaker rating. But the second circuit, I need to take the maximum demand, right? But this is the I full load, this is the diversity factor. That's why 7.82 times 0.8 comes from here. That's how I get this number, 47.82 times 0.8. Then the rest 100%.
Oh, yeah, I know. Then for the DBB, right, I don't understand how you get the numbers also.
Okay, DBB, now because DBB got many circuit inside. Can you see?
Yeah.
We got this one, the lighting circuit got 8 circuit. Then the SSO circuit got 17 circuit, no? And because this DBB is 3-phase, so I need to do a mini load balancing. This is what I'm doing here. In order to get the maximum demand for this DB.
But
I'm doing a mini load balancing.
But I don't understand where the 3 and the 6 at IND come from.
The what? Oh, this one.
Yeah.
This one here. This one.
Yeah, on the left.
Okay, you count the number of circuit. For example, now I'm looking at phase 1, right? Phase 1 means this one, right? So if I look down this column, how many lighting circuit have I got?
3 only.
3, right? That's why I took 3. and I only take one of them, 6.26, right? So this
Yeah.
is this one, this plus this 3 circuit plus, right? 6.26 plus 6.26 plus 6.26, right?
Mm.
That's why it's 3 times 6.26. But then the diversity factor I use from here.
Oh, then why the yeah, I understand. But then for the 7.16 one,
Same. I count 1, 2, 3, 4, 5, 6 circuit.
but why got 6?
Because total is 17 circuit, right?
17 number.
17 number of 20 amp circuit. 17 numbers
Yeah.
of 20 amps rated circuit.
Ah.
So actually total is how many circuit? Is 17 circuit, right?
Ah.
17 circuit, how to distribute? So this is how I distribute it. 1, 2, 3, 4, 5, 6, 7, 8, 9,
it's like
10, 11, 12, 13, 14, 15, 16, 17.
Oh.
So I'm doing
Okay.
a load balancing throughout the 3 phase. Okay, but when I come to calculate the maximum demand, I look at individual phase. That means I look at L1, I calculate this one. I look at L2, I calculate another one, next page. Come to this one, I calculate. That means first one I calculate. Second one, I use 3, 5 only. Because if you look at it, the middle one, I got 1, 2, 3. Here got 1, 2, 3, 4, 5 only. Okay?
Oh, so it's just you add up the L1, L2, L3 lah.
Yes, yes. So the third one got how many circuit? 2 circuit here only, right? Then here got how many circuit? 1, 2, 3, 4, 5, 6, right? So that's the reason why the third one only got 2 here, got 6 here.
But how you choose which one to give 6, which one to give 5?
Okay, this one is just follow the flow. You see, first I use the lighting, right? I start from left to right. So 1, 2, 3, 4, 5, 6, 7, 8, right? So when I want to continue, I start for the SSO, I start from here.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 here.
Oh, okay, I understand.
So basically it's very like, I try to distribute the load as evenly as possible.
So it's actually quite easy lah, but got a lot of steps only.
Right. So instead of, if I really want to calculate like this, I have to write a very long one, right? I have to do like L1, L1 I have to do 6.26 times 0.9 plus 6.26 times 0.9 plus 6.26 times 0.9 and then plus 7.16 times 1 plus 7. Then it's going to be very, very long, right? So that's why I calculate like that lah.
Oh, okay. Yeah.
So this is how I have to do this mini load balancing so that I can transfer the maximum demand to my main calculation. When I come back the main board, right? Notice that value all come from there. These values this value I take from the earlier calculation.
Okay, I understand.
Okay,
yeah.
So at least you observe it. This is the process. This is how we do the load balancing and then we transfer to the main board. Okay.
Yeah, okay. Thank you, Joe.
Okay, so now I have finished all the calculation. It's still, the story is still not ended. Remember what are we doing? After I finish all the calculation, I get all the values that I want, right? Now I'm ready to draw the single line. So how to draw the single line? This one is the challenging part. So if I go to the lecture note, if I look at lecture note, topic 5. Okay, so please go and look up your lecture note for topic 5, even though you haven't the Miss Lau and Mr. Koh have not finished, right? But the single line example is already shown inside here. If I scroll down this lecture note, whatever I talk about here, of course, the lecture note, they do nicely. Right? Whatever I explain is all the same. At the end, I need to draw my single line diagram. So how does my single line diagram look like? Like this. Okay. So in your PBL 2.2, please draw a very, very, very nice single line diagram. Okay, this is the one I used to explain to the other class yesterday. So your single line diagram must look something like this. Now because the load is much, much bigger than our house, I cannot use the single line diagram of our topic 2. Our topic 2 is only for our house because the load is very, very small. It's less than 100 watt. It's less than 100 ampere, right? So now my circuit breaker is okay. Maybe I just let me copy and paste this one. Easier to talk. Just hang on a moment. Let me clean up this one. Let me clean up this one. Let me find a way to clean up this one. How do I clean up this? How do I clean up this? Okay, I want to clean up this one so that I can use this to explain. This be a better way for me to clean up this. Okay, after we have done all the calculation, you got all the circuit breaker rating, everything, right? You must come here. You must draw something similar. Okay, draw something similar. Of course, you must incorporate the values. Incorporate the values of all the which is similar to the information provided in PBL 2.2. All right, now what do I mean by that? Now this guideline, this circuit breaker, this single line diagram drawing is just a guide because it is based on the example here, right? But if I were to draw the single line for my PBL assignment, I will have to draw it slightly differently because it must reflect whatever that my information, it must tally with my whatever information that I have from PBL 2.2. So I can borrow this template, and then I must change the relevant information. Now, what is the relevant information I'm talking about? Now, just now, anybody remember what is the circuit breaker rating for the incoming for our calculation? Just now we did the calculation already, right? It tells me the incoming must be 250 amps TPN, right? So I go to my single line diagram. This one must change. This one must change to 250. Okay. Now the minute I change this to 250, there are a few things I must change to tally with it. All right, there are a few things I must change to tally with it. So here is 250 ampere. The minute I change this one must change. This one must change. This one must change. It all must be the same. All right, so my single line diagram, notice that for the three phase, it has more things now. You have a voltmeter, it has an ammeter, it have a relay, protection relay, overcurrent and earth fault. It have indication light, three phase indication light. you have three-phase indication light as well. You also have a selector switch for me to change the reading to read each of the phase voltage. And you also have a selector switch to allow me to measure, see what is the current in each of the phase. All right, so this is the incoming. Then outgoing, I must, because we have 6 circuit, right? So my drawing here must tally with the 6 circuit. So circuit number 1, I can label like that. Circuit number 2, number 3. Now I don't like this kind of drawing because this is the American way. So usually what I do is I change this to single line. I change to single line means I draw like this. Okay, I draw like this. I can still reflect the same kind of answer. Right? So I have circuit 1, 2, 3, 4, 5, 6 only. That means the rest I don't need. Well, I can, okay, up to us to change. So we only have 6 circuit, right? So in theory, my single line diagram, I will not need to have this guy. I need to have this guy. I can also reduce the number of spare because it's okay to just provide 2 spare will do. Okay, so I have 6 circuit. Now each circuit must reflect what we have calculated. First circuit is 20 ampere SPN. At the end is dBA. So first circuit, I have a dB at the end. At the end of this is the dB. So I can change this on to a dB. Just draw a little box. dBA. Because this is single phase. So if it's single phase, this is 20 ampere SPN. Now, whether this board, is it going to be MCCB or MCB, you need to do one calculation first. Because we need to determine whether the breaking capacity, what is the value? Anybody remember how to determine the breaking capacity now? How to determine this value? Anybody remember how to determine the breaking capacity? Remember in topic 3, topic 3, we have one page that gives us a clue how to determine the breaking capacity. If you turn your notes to this page, can you see this page? My breaking capacity will depend on my supply capacity. Remember just now my calculation, when we calculate the maximum demand for this board, right? What was the maximum demand? After I calculated all this, right? My maximum demand is 189.17 ampere, right? Then I can convert this to kVA. How do I convert this to kVA? Anybody remember? I want to calculate the power in kVA. Anybody remember what formula must I use? This one important because then it will determine what is the breaking capacity I must use. Can you remember how to calculate? Just now I did one already, right? Is there anybody there can tell me how to calculate, how to convert from ampere to kVA? Hello? Remember I did one here. I did one at this spot. Maximum demand for the dB is how many ampere 3-phase, right? Then I want to convert to kVA. What did I do? Remember this one? So I can do the same for my main board. Right? I do the same for my main board. kVA is equals to √3 times 400 volt times 189.17 ampere. That will give me kVA. So what does that mean? 3 square root times 400 times 189.17. 189.17. That gives me 131.06 kVA. So what it tells me is that is the supply requirement, right? 131.06. So if I go back to this table, 131 is in this category. 131 is in this category, right? So therefore, my breaking capacity is 25 kA, 3 seconds. That's where we get the 25 kA, 3 seconds from. So once I know that the breaking capacity is 25 kA, it means that I can only use MCCB, because MCB don't have breaking capacity so high. Maximum for MCB breaking capacity only around 15 kA. In other words, my single line diagram, all my circuit breaker must be MCCB. MCCB, this one. So you can, instead of writing MCCB everywhere, right? You can make a note here. Note. All circuit breaker use are MCCB. All right, so you don't have to keep on writing here MCCB, MCCB, MCCB all over the place. You only need to write 20M SPN, good enough. Right? Then I look at the other circuit. Circuit number 2 is 63 ampere TPN. So I cannot use MCB, so I must use MCCB. So my second one is 63 ampere. 63 ampere TPN. But this one is not a motor circuit. This is a dB again. So I need to draw a dB inside here. So this one is dB, dBB. But because it's 3-phase, all right, then you slowly go down all the way and complete the drawing. Okay, so this is the single line you must draw. Draw nicely. Please use a ruler and everything to finish up your single line. Of course, all these are not relevant. All these need to change. Okay, all these need to update to according to your design. Anybody, any question about the single line drawing, how to draw? Anybody got any question about drawing the single line diagram? So please go to your lecture note. Lecture note topic 5. Look at the example here. Actually, this is not a good example because this is part of an exam question. There's one that is more better one to see. Don't seem to have a good diagram for you to follow. This one is not a full diagram. It's an example of part of an exam question. Right, complete the missing label in the single line. Oh, okay, this one can. Because this one is just asking you to finish up based on the calculation here. Draw the single line diagram. Right, so you can still use all these incoming are still relevant. It's just that the value, if this is 200, notice they're all the same, 200. For our case, it's 250, so all this change to 250. Then the outgoing, you must change to that 6 circuit we are talking about. So still can, not say cannot. Anybody got any final question about how to draw the single line diagram? So after you have done the calculation, you have done the single line diagram, right? Now, if you go back to the PBL 2.2, the PBL 2.2 has a nice table. There's a table there. You can fill in using the table to fill in all the information you need. Same thing. You just fill in all this information. Make sure you submit this back together with your PBL 2.2 submission. So your PBL 2.2 submission have three important things. One is all the calculation that I've just shown you. All right. When you write your report, you must follow this. Objective, just copy from here. Copy this objective, right? Then introduction and theory. This one, you read the lecture note and then you write what you think you are supposed to do here. Three-phase load balancing, circuit breaker sizing, how you size the circuit breaker, things like that. And then this is where you show all the calculation. Show all your calculation. This table is to summarize all the calculation. So fill in this table, fill in all these things, and refer to the notes that I have done. And then finally draw the single line. Right? Then you can submit already. Right? Finally, you submit a single line.